Time travel. It's one of humanity's greatest fantasies. To go back, fix mistakes, meet your ancestors, or see the future unfold. But what if actually doing it could destroy everything? And this is why. For centuries, time travel has been the ultimate what if. It's been the plot of countless books, movies, and dreams. But beyond fiction, real physics suggests time travel isn't entirely impossible, just extremely dangerous. Einstein's theory of relativity showed that time isn't fixed. It bends, stretches, and warps depending on speed and gravity. The faster you move, the slower time passes for you. Astronauts on the International Space Station actually age a little slower than we do on Earth. It's called time dilation, and it's a real form of time travel, just into the future. But traveling backward, that's where the problems begin. According to Einstein's equations, it might be possible to bend space-time into a loop, something scientists call a closed time-like curve. If you could create one, you could, in theory, return to an earlier moment. But doing that might break the very fabric of reality. Imagine this. You travel back in time and accidentally prevent your grandparents from meeting. That would mean you were never born. But if you were never born, who went back in time to stop them? This is called the grandfather paradox, and it's one of the biggest logical problems in physics. Another paradox is the bootstrap paradox, where something from the future causes itself to exist in the past. Imagine giving Shakespeare a copy of Hamlet, and he publishes it word for word, meaning he never actually wrote it. So where did the play come from? You've created an object or idea with no true origin. Paradoxes like these reveal something profound. The universe doesn't like contradictions. Many scientists believe the laws of physics simply wouldn't allow time travel into the past, because it would create impossible feedback loops that violate causality, the rule that cause comes before effect. Even if you could somehow build a time machine, say using a wormhole, a tunnel through space-time, it might not stay stable long enough to work. Wormholes require negative energy to hold them open, something that's only theoretical. And if one were created, even the tiniest disturbance, a single photon of light entering it, could trigger a runaway cascade of energy. The wormhole could collapse, explode, or distort space so violently that it tears apart reality itself. Stephen Hawking famously proposed the chronology protection conjecture, the idea that the universe actively prevents time travel to the past. In his view, the laws of physics include safety barriers that stop paradoxes before they can occur. In other words, time travel could destroy the universe, so the universe simply doesn't allow it. But what if somehow, someone still managed to travel back? Some theories suggest the moment you change something in the past, you might create an entirely new timeline, branching off from the original. That means you wouldn't erase your own existence. You'd just create a new version of the universe, where events unfold differently. This is the multiverse, or many worlds interpretation. It sounds safe, but it introduces another problem: energy conservation. Every time a new universe splits off, where does all that energy come from? If timelines can multiply infinitely, the total energy of the cosmos would spiral out of control. The universe might not survive such instability. There's also quantum mechanics, where particles seem to behave as if they already know what's going to happen. In some quantum experiments, the outcome can change depending on whether or not we observe it. Some scientists think time itself might be woven into quantum uncertainty, that the future and past are connected in ways we don't fully understand. If that's true, then even the smallest action in the past could ripple across time, rewriting history on a cosmic scale, collapsing probabilities, destroying order and unmaking the timeline we know. So while time travel might sound thrilling, it could unravel the one rule that holds the universe together: cause and effect. Without that, nothing makes sense. Every action could undo itself, and existence would collapse into chaos. But here's the twist. In some ways, time travel is already happening. Every moment we move forward through time at the speed of 1 second per second. And our universe itself might be a form of time machine, constantly expanding, carrying the past and future along with it. So maybe the real danger isn't time travel itself. It's trying to escape the flow we're already in. The laws of physics may have built-in safeguards to keep us moving forward, to protect reality from tearing itself apart. Time travel could, in theory, destroy the universe. But maybe that's exactly why we'll never be able to do it. And this is why time travel could destroy the universe.